Okay, I wanted to give a counter opinion to what we did in lab on Thursday. Remember, lab Thursday, you were looking at the different layers of sediment and understanding how that is interpreted by scientists. This here is an article from the Institute for Creation Research, which of course scientists say, oh, it's not science, they're studying creation, where they have gone through and examined the layering the way that you did. And what they report is that they find there's lots of problems with the uniformitarian explanations. So I'm obviously not reading this article, but I put it on the first slide of the presentation, which is, seriously, it crashed. Yeah, we're starting well. On the first slide here, there's the link to it's a simple URL. So you can go read it at your leisure to get another way of viewing the data. It all starts by looking at the same dirt, and it's how you interpret it. Okay, we're going to continue on today, and I don't know why I did that before this, because of course it moves back as soon as I do that, and talk some about the atmosphere. So we're going to talk about the atmosphere today. I believe Wednesday will be a review day, and then Friday is an exam. Is that right? Is it Monday? I thought it was Friday. Anyway, we will have a quiz on Wednesday. I'll let you know beforehand. A quiz. We would have had a quiz today, but I didn't get it ready. So, the components of the atmosphere. The atmosphere is, well, it has oxygen because that's what we need to breathe, right? If we didn't have oxygen, we would kind of be sad. But that is not the major component of the atmosphere. That's only about 21% of the atmosphere. The vast preponderance of the atmosphere is nitrogen, 78% nitrogen. So when you breathe, you're breathing a lot of nitrogen. Is that a problem? Clearly, it must not be, or we have real health issues, right? So it's not a problem. The nitrogen comes in, the nitrogen goes out. But then if you look at the other things, argon gas, what can you tell me about argon, neon, and helium? They're noble gases. Those are noble gases. How are those going to affect us?
They're so noble that will something.
They're so noble that they won't harm us because they're inert. They just don't do anything. They hang around. They're very happy all by themselves, and they don't want to mess with our other molecules or our other atoms. So those are just noble gases. They don't cause a problem. And if you look at the percentages, argon's 0.9%, and you're like, wow, that's a very tiny amount, roughly 1%. And then you look at neon, which is the next most common, and it's like, wow, there's none of that. And so the amount of neon through hydrogen on this, as well as the ozone through nitrogen dioxide in the other column, those are very, very small components. Now, what's the difference in the left column and the right column? The left column is gases that are always in the air. The right column are ones that will vary, maybe missing. Things like, sulfur dioxide and nitrogen dioxide. Where do those come from?
I don't know.
They come from incomplete. Okay, nice writing. Combustion. So, like if you have a car that's not that's a polluter, that's not burning the gas well, and it'll produce more of those things. Your catalytic converter will help to remove those. But those are pollutants that we introduce. Carbon monoxide, that comes from burning. Ozone, we had a question on one of our homework assignments about making ozone. We can make ozone. In fact, if you have an electrical fault where you have arcing, you smell something when you have electrical arcing, what you're smelling is the ozone that's being created by that arcing. Right, so we can make ozone, but we're not going to, well, it's not that good for us to breathe. And we're not going to make enough to make a difference. And carbon dioxide, we also produce that by things like burning. Carbon monoxide is the one that you can get very significant health effects from. Here's a very bad thing to do. When I was on the ambulance company, we responded to only one multi-casualty incident. And it was people who were having a barbecue for Labor Day weekend, but it was rainy. So they put the barbecue inside the house. Yeah. Then they went to bed, and somebody woke up in the middle of the night not feeling very well, and then they went to tell somebody they weren't feeling any very well, and they couldn't wake them up, and found out everyone couldn't wake up. And so, of course, they called 911, and we came, and they all had heavy carbon monoxide that they breathed in. Nobody died. My patient passed out in the ambulance, which scared me, but that's because I was a newbie, didn't know what I was doing. The patient just hyperventilated because they were scared. So don't do that. Don't barbecue indoors. Yeah.
I don't know. Like carbon monoxide is obviously CO.
Yeah.
Then why is carbon dioxide not more potent?
Well, you have different bonds, right? Because carbon monoxide is going to be with two pairs like that, and carbon dioxide is like that. So in terms of how they're going to interact with other atoms, they interact differently because you have to do different things to make them bond. Like if you look at carbon dioxide, that's nonpolar, whereas carbon monoxide is polar, right? So you have differences like that make them so our body treats them differently. And carbon monoxide will displace O2 in hemoglobin. That is, it will attach to your red blood cells and keep oxygen from attaching. That's not a good thing. Now, carbon dioxide attaches, but it will allow itself to be replaced by oxygen. That's what's normally happening. Oxygen attaches, goes, you have the oxygen metabolized, you have carbon dioxide that replaces it, comes out, and you have an exchange cycle. But the carbon monoxide stops that exchange cycle and just stays stuck. Okay, so that's the composition basically of our atmosphere. The atmosphere is broken up into layers based on what's going on. So the lowest layer is the troposphere. This is just showing the layers, and then I'll go through talk about each one carefully. I should have put this picture on every page like I did last time I did something like this. So the troposphere, that's where we have our weather, right? So things like last night we had a storm. Depending on where you were, you might have had some hail. That's stuff that's occurring down the troposphere. The troposphere has 90% of the air. So that's where the vast majority of the weight of the air is, because that's where the air is present. And as you go up in the troposphere, the temperature cools by about 6 degrees Celsius per kilometer. So if you get up to the top of the troposphere, up around here, whoops, I went too high. Up around here, the temperature is about minus 50 degrees Celsius. Right, so that's cold. Airplanes fly at the top of the troposphere because you're getting up out of most of the air, which means you have a lot less air resistance. Less air resistance means less fuel consumption. Of course, it also means less lift when you have thinner air, but you have wings that you can, make the wings so they'll give you enough lift up there. So, this shows commercial air jet here, a spy plane even higher. Why spy planes go higher? They're harder to detect up there. So there's our troposphere. Above the troposphere here, we have the ozone layer. What's the ozone layer? That's the layer where the O3 occurs. Now that O3 absorbs ultraviolet radiation. As a result, things get hotter. So when you go into the stratosphere, you have the ozone that's absorbing ultraviolet light, converting the sun's energy into thermal energy, so it gets hotter in the stratosphere. So the temperature you can see here is going back to getting hotter in the stratosphere because of the ozone absorbing ultraviolet radiation. Get up to the next one, the mesosphere. Meso is, the middle. The mesosphere up here, it's getting cooler again. There's nothing that's absorbing radiation, so it's getting cooler. And that's where you have cool things like the auroras, aurora borealis and whatnot. The ionosphere is not shown here because it's basically a region that includes the top of the mesosphere and the bottom of the thermosphere. The thermosphere, the last one that's shown in our picture, once again will absorb energy and get really hot. Depending on what's going on, it might be somewhere between 500 degrees Celsius and 1500 degrees Celsius up there in the thermosphere. Hence the term thermosphere. It's hot. And then there's one more layer above the thermosphere. That's the exosphere. The exosphere is the boundary where you're going into what we consider outer space. You're basically outside of the air that the Earth holds. So this picture lays it all out. Now we have just details, which I can go through reasonably quickly because I've talked about everything on these. The only thing on this slide I didn't mention was the height of the troposphere. It says 16 kilometers at the equator and 8 kilometers at the poles. There's actually the boundary is defined by what's happening with the temperatures, where the temperature goes from declining to increasing. And so it depends on where you are and what's going on in the weather, the elevation of that. So it varies. Even here at one location, it will vary with the weather. The stratosphere goes up to 50 kilometers. Like we said, it has the ozone layer, so it's getting hotter there. The mesosphere going from 50 to 80 kilometers, temperature decreases again. The thermosphere gets hotter again. I put here up to 1500 degrees Celsius. Remember I said it depends on the conditions, what the temperature is going to be. So once again, the same location. If the sun's doing crazy things, it might be 1500 degrees Celsius. If the sun's doing nothing special, it might be 500 degrees Celsius. But still, it gets hot up there. It's very, very low density. So even though it's super hot, you would feel cold because you wouldn't be getting hit by air molecules enough to feel hot. The ionosphere is a region between the upper including upper mesosphere through lower thermosphere, and finally the exosphere. The ionosphere is called the ionosphere because you have ionized molecules. That is, you have things like N2 plus because an electron's been removed from the nitrogen. And so that ionized molecule is going to behave a little bit differently. And in the ionosphere, that's where I hope I didn't say this wrong, that's where we have our auroras, things like the northern lights and southern lights are occurring there. So that's a longer than a quick rundown of the different portions of the atmosphere. Which one, actually, let me go to the clicker question instead of asking it and then having you answer it again. In which region does weather, i.e. the clouds and the storms, occur on Earth? Well, see, because it was an important one.
Crunch. That was my question. Right? Now what do I do? Good picture sheet.
I do.
Darn. Well, at least I know I'll get some quicker questions, right?
There's an offset with the answers again. I was looking, I was like, wow, everybody is answering exosphere. It's going on.
Well, spoiler alert, the answer is not exosphere.
Thank you for that spoiler alert.
Sorry.
Okay, still waiting for Candace, Carmen, and Raquel.
Crud, I thought I had the perfect question lined up.
Well, Carmen's not here, so waiting for Kansas and Raquel. All righty. We had 3, 1, 1, 12, 0, 0. Okay, so now it's pretty well laid out. Let me ask, and I'm going to ask a bunch of people just in order of the layers. So Vanessa, what is the lowest layer of the atmosphere? The troposphere. And that's what 12 people answered. Are they correct?
Yes.
Yes, they are. The troposphere, the one that we live in, is the one in which our weather occurs. Not surprising. So this was the correct answer. So Vanessa's got the lowest one. Next lowest. There's only one person not here. Jackie, what's the next lowest layer?
Stratosphere?
Yeah, stratosphere. Kind of surprising because what do you tend to think stratosphere means? Yeah, we think it's way up. Well, compared to the troposphere, it's way up, but compared to the overall atmosphere, it's not. Okay, now going into the ones that are not so common for us to hear. Tiffany, what comes after the stratosphere? Okay, I should have written on here, by the way. Troposphere was 1, and then we had stratosphere was 2, and then we have the mesosphere.
Yeah.
Okay, the mesosphere. What does meso mean?
Middle.
It's in the middle, right? And then, now notice there are 2 answers that a person could choose for this. Try to choose the one that is, well, Casey, try to choose the one that starts in the mesosphere. That helps out.
The thermosphere.
The thermosphere is the next one, but there's one that's part of mesosphere and part of thermosphere.
Ionosphere.
Right.
And then, oh wait, I can't say that.
So the ionosphere, I'm going to put 4A, and then thermosphere, I'll put 4B. Because 4A, there. Ionosphere is 3B and 4A. Because it's part of the mesosphere and part of the thermosphere. So what's going on with the ionosphere? We have
That's the one where
we have ionized molecules. We have molecules that, because of solar radiation, they've had electrons kicked off. Okay, and then thermosphere. Why is it called thermosphere? Because that's the place where it gets hot. What's the hottest temperature you might reach in the thermosphere?
1500 degrees.
The 1500 degrees Celsius. And then what's our final layer here? Exosphere. I obviously didn't count on some or call on someone because by process of elimination, you get the last one. Okay, so those are layers of the atmosphere. Another follow-up, actually not follow-up, introducing a new area. What causes seasons on Earth? I think we talked about it before, but I know we talked about it again today.
Oh, I think I know this.
Yes, you can see through that, right? Okay. Hannah, Vanessa, and Raquel. All right. 3 said the distance between the Earth and the Sun. 0 said the distance between the Earth and the Moon. That was good. 11 said the tilt of the Earth's atmosphere. One said the variation of solar radiation, and one said the variation nuclear. Is that right?
Yeah, there's one on the last three.
Yeah, okay. They're offset, and so it's hard for me to. Okay, so this one here, I'm not going to ask somebody because we haven't talked about it. The correct answer was the tilt of the Earth's atmosphere or axis. 3 people said the distance between the Earth and sun, and that's what a lot of people start off believing because they know the sun is hot. And so if you get closer to something hot, you're going to receive more heat, hence you will get hotter too. So that's what a lot of people believe, but it's not right. So the Earth is tilted. Now this isn't a globe, it's not the Earth, but we'll pretend it is. So the Earth is tilted by 23.5 degrees, which is, this is March, 40, 50, 60. Okay, that's about how much the Earth is tilted. Now when we say it's tilted, we have to define what that means or it becomes confusing. The Earth is orbiting around the sun, and so our reference is the direction it's orbiting around the sun. So if this was a globe, this line here would indicate where the ecliptic is, that is where the sun is as the Earth spins. You know, as the Earth spins, you see the sun over that line. Now, if the sun is over here, the sun is going to shine, and which part of that, just pretend it's a globe, which part of the globe is going to get the most sunlight if the sun's shining from here?
Where that line is?
Okay, it's going to be where this line is, and so you would have sunlight hitting from here to here, right? Sorry, not everyone. Let me go on the other side. That's a smart move. If the sun is where that monitor is, you'd have sunlight hitting from here to here. On this side. Look at the North Pole. North Pole is getting no sunlight. Doesn't matter how the Earth rotates, there's no sunlight hitting the North Pole. It's totally in shadow. How much heating is it going to get from the sun if it's totally in shadow? None. So it's going to get cold there. What season would we call it when it's cold? Winter, right. Okay, not a tough question. So it's definitely going to be cold up there. It's going to be winter. What about down here, the South Pole?
Summer.
It's never going to have shade, so it's constantly sunlight. Now, it's not going to be the hottest down there. It's not going to be the hottest down there because we said the sun is most directly hitting here. So it's going to be hottest in this region. Now, the equator of the Earth is up here, so this is south of the equator. So in the region south of the equator, you're getting the most direct sunlight, and hence it's summer in the southern equator with this arrangement. Now, the Earth orbits around the sun. Of course, I could take this around, but it's easiest to stay here and just rotate this picture. So now you're viewing after it's gone halfway around. Now where are we getting the most sunlight, north or south? North. And so that would be summer in the northern hemisphere, winter in the southern. So the seasons reverse between northern and southern hemisphere. One of your homework questions is just that. It's asking about, it's really actually a funny question. In January let's say Nebraska, it's winter. What month and season is it in Australia at the same time?
Summer. Spring.
What month?
It's the same month.
Yeah, it's the same month. That's the part that I think is kind of funny. In January, what month is it if you're in Australia? Well, I don't know. I only know the months in the United States. Yeah, so it would still be January, but it's going to be summer instead of winter. Hence the movie we loved when I was a kid, Endless Summer, about surfers who just go from northern hemisphere to southern hemisphere so that they can surf year-round in summertime, or they can just go to Hawaii. Yeah.
So in Australia, do they have a summer break in like January?
Okay.
/ do they have Christmas? Do they do Christmas?
Yes, they do Christmas. But I mean, that's the kind of question that I ask as well, because I've never been there, and I was wondering, do they call it winter when it's hot? No, they call it summer. So there's some, they say it's summer when we say no, it's not. They say it's winter and we say no, it's not, because for them it is summer, for them it is winter. So summer and winter don't go with, that's the point of the question. Why has
They
you
don't go with months.
go with where you are and month. So that's why I had you specify the obvious. Yes, it's still January, but it's January and summer in the Southern Hemisphere. But yeah, what do they do for their school year? I would hope they do it like we do, because why do we have summer break? Because that's the best time for kids to run amok, right? And so I would hope that they would have a summer break over, what we consider the winter months. But I don't know what their school calendar is. I think that's the way it is, mostly because Moodle has two different refreshes, one that occurs in the middle of our summer break and one that occurs at 6 months off, which I assume is their summer break. Okay, so it's the tilting of the Earth that is responsible for the seasons. As the Earth orbits around the sun, different parts of the Earth will receive more direct sunlight and thus more heating. There are special demarcations that we often don't even think about. The tropics. Growing up as a kid, I lived in the tropics. I didn't know what that meant other than, well, we have the rainy season, we have the dry season. It's hot year round. Well, the tropics actually has to do, again, with this tilt. In this location, you have direct sunlight 23.5 degrees north of the equator. And in this season, you have direct sunlight 23.5 degrees south of the equator. The tropics is the region between those 2 points. So you have the northern tropic, which I believe is the Tropic of Cancer, and the southern tropic, which is the Tropic of Capricorn. And everything between those 2 points is considered the tropics. What's the tropics? It's the range where at some point during the year, the sun will pass directly over your head. That's what defines the tropics. And so you're going to have the most direct situation for sunlight in the tropics. Hence, you're going to have the most heating. It's going to be the highest general temperatures. We also have the Arctic and Antarctic circles. Once again, defined by the same thing. From here on, it will be in complete shadow. And you go around to the other side and you'll have the same thing on the bottom from here on. So those regions, 23.5 degrees from the poles, are the Arctic in the north and Antarctic in the south circles. So they're based on where the sun hits. The Arctic and Antarctic circles mark the places where you're going to have at least one day when the sun never rises. The Tropic of Cancer and Tropic of Capricorn, everywhere in between, mark the places where you're going to have at least one day when the sun passes directly over your head. So now, talking more about this with the slides instead of just explaining. Hopefully nobody ever says, yeah, Webb just reads the slides. Yeah, I've seen memes, people talking about, I go to class, person just reads the slide. Why hope that I don't get accused of that. So the sunlight is giving off radiation. We have the visible radiation, what we can see. The vast majority of the sun's radiation is in the visible range. It has some that's in the ultraviolet range. We get protected from a lot of that by the ozone layer. We also have the infrared. We have radiation that is in longer wavelengths that we can't see that are responsible for more heating. You and I are currently giving off infrared radiation because we're hot. So infrared radiation, even we give off. So the Earth's surface is primarily infrared because the Earth is not that hot. The sun's is primarily visible. That leads to the greenhouse effect. Everybody here has heard the term greenhouse effect, right? The greenhouse effect is basically, here's the Earth. It has its atmosphere around it. And then we have out here the sun. And light from the sun goes right through the atmosphere. Most of it goes right through the atmosphere. Comes in and heats the Earth. And because the Earth is heated, the Earth then gives off radiation. But the Earth's radiation, because it's not nearly as hot, is longer. So the radiation coming from the Earth is a much longer, okay, you can't tell the difference in those wavelengths. I'm just going to start over. Solar radiation is a short wavelength. So that's coming into the Earth. The Earth's radiation is a longer wavelength. And that longer wavelength is largely absorbed by the Earth's atmosphere. And so that means heat can come in from the sun, but heat can't escape from the Earth because the frequencies the Earth is giving off are much longer. So if more heat comes in and less heat leaves, what happens to the temperature? It goes up. Well, as the temperature goes up, the amount of radiation the Earth gives off increases. And so finally you reach a temperature where you can achieve a balance. What would happen to the Earth if there was no greenhouse effect? No greenhouse effect? We would freeze. We'd be popsicle Earth if there's no greenhouse effect. The greenhouse effect is necessary for us to have life on this Earth. But if the greenhouse effect is too strong, then what happens to life on the Earth? Yeah, we won't have life on this Earth if the greenhouse effect is too strong either. If you look at Venus, now Venus is closer to the sun, so it gets more radiation. But the temperatures on Venus are an outstanding somewhere around 800 degrees Celsius. We would simply be incinerated there. Also, the atmosphere is completely caustic to us. It's caustic to everything. The Russians have landed a number of spacecraft there, and I think they had the longest surviving one survive for like 90 minutes before it was destroyed by the conditions on the surface of Venus. Why is Venus so hostile? You're supposed to answer because men are from Mars and women are from Venus. No, that's of course not the reason at all. I just think it's a funny thing to say. It's probably misogynistic, but you understand that I did not mean it seriously, right?
A class like 96%.
I know. There are two men here.
Good choice.
Yeah, good choice. Smart move, Webb. Anyway, no, it's because it has a runaway greenhouse effect on Venus. Venus is, by the way, the, quote, female planet. All but 2 of the features on Venus are named for women. Has nothing to do with the weather, just in case you think that there's some misogynistic plan here. So that it makes sense to say men are from Mars, women are from Venus, because Venus, by international convention, has everything's female names, Sacagawea and whatnot. So the greenhouse effect, we believe that Venus never got cold enough for liquid water to form on its surface. Hence, it never took things like carbon dioxide and encapsulated it in rock. And so it has a runaway greenhouse effect. The Earth got cool enough for liquid water to form, takes carbon dioxide out of the atmosphere, and we have a much more habitable is what I meant to say, but I put the emphasis the wrong place and then it comes out horrible. Habitable environment. Now, getting back to, I've talked about everything on here. Direct sunlight will give you more heating than indirect sunlight. That is, if the sun is just skimming the Earth here, it's going to spread its energy out over a big region and not nearly as much energy will be received by any one location. So it's not going to be as hot up here as it is here, where you have the direct radiation. So that makes it's easier to understand. Yeah, that's why the equator, where you have the most direct radiation generally, is going to be hotter. And so we actually mark the beginnings and endings of seasons by the time when the sun is on the points I mentioned, on the Tropic of Cancer, on the Tropic of, well, this one here would be Capricorn, up here would be Tropic of Cancer, on the Arctic Circle, on the Antarctic Circle. So when the Earth is, the sun is never on those, excuse me, and when it's crossing the equator is the others. So when the Earth is tilted, so the sun appears the lowest in the sky, the farthest south, then that would be this position here. We call it the solstice, and that is the official mark for the beginning of winter. So winter began somewhere around December 22 or 23, or 21. It doesn't say 21 there, but it occurs on December 21 as well. It depends on the year. So that's when the winter starts. Most of us think winter starts earlier than that. That's the time when we here in the Northern Hemisphere, that's the day when we'll receive the least solar radiation. Is that the coldest day of the year?
No.
No, it's not. When's the coldest day? June 6th? Really?
What?
It's usually January 6th. Okay.
No, I said June, let's be honest.
Yeah, okay. That's what I thought. It's generally late January to early February is the coldest day of the year. Why would it be colder in late January, early February when we receive the least direct sunlight end of December? The answer is simple. We're not in equilibrium. Equilibrium would mean that we're always maintaining the heat flowing in and heat flowing out is equal. But if there's less heat flowing in than out, then we're going to be having a net cooling, and we'll continue to cool even if the heat starts rising until we have more heat coming in that's going out. And so there's a lag, and so it's in late January, early February where it catches up. And then likewise, the equinox, these are both equinoxes. That's when the sun is shining like this, and so the sun is over the equator. And so we call the equinoxes the moment when the sun is over the equator, and that marks the beginning of fall and spring. So here we had spring starts March 20 or 21 when we were on the equinox. And fall will start September 22, that's Mom's birthday, or 23 when we're at the next equinox. And of course, summer starts June 21 or 22 when we're receiving the most radiation, when the sun is rising 23 degrees. Well, the sun is at its highest point, 23 degrees north of the equator. We're 40 degrees north of the equator. If the sun is 23 degrees north and we're 40 degrees north, what's the angle between overhead and the sun?
17.
And of course, it's 23 and a half, but we're just going to round numbers. So it's 23.4 if you want to be really accurate. So when the sun is, so here's our, that's horrible drawing. Here's the equator. Here's the ecliptic, the path, wow, is the path the Earth takes as it orbits around the sun, but what we think of the sun passing through. And then we have our location, which has to be a constant 40 degrees north. So we have, this is 40 degrees, and that other one was, and we're just rounding off to 23 degrees, and 40 minus 23 is the 17 that was given by Brandon correctly. So the sun will only be 17 degrees away from straight overhead on the summer solstice. But what about on the winter solstice? If this is 23 degrees, and then we have this angle here is 40 degrees, how far is the sun from overhead at noon on the winter solstice? 63 degrees. There's only 90 degrees in a right angle. So it's 63 degrees from overhead or 27 degrees above the horizon. The sun doesn't get that high in the sky here in the middle of the winter. So you know, if you were to go out and look at where the sun is at noon every day, you would see that it's going up and down as we go through the seasons, which is why we have seasons. Okay, air motion. What causes winds? What causes our weather? It's driven by heat. That is, we have heating from the sun as well as some from the earth, very, very small amount. That heats up air. The hot air then responds to being heated up. It expands. As it expands, it becomes lower pressure. It floats up. And so that's the driver for what goes on in our weather. Convection is what we call the cycles where hot stuff floats up. So if you have something like an ocean, the temperature of the ocean stays pretty constant. During the daytime, the land, if you're receiving nice sunlight, will heat up. So it'll be hotter over the land, cooler over the ocean. What happens to the hot air over the land? As it heats up, what happens to its density?
It's less.
becomes less dense. And if it becomes less dense, what does it do?
Rises.
It floats up. So you have air goes up over the hot earth. The cool air from the ocean then is going to flow in to replace it. And so as the earth heats up, you'll have air blowing from the ocean onto the land, helping to keep it cool. When the sun sets, the land, because it has a smaller specific heat, will cool much more rapidly. The water stays about the same temperature. Then it just reverses and you'll have a breeze blowing out to sea. And so those are, well, probably because I grew up near the ocean, that's something that makes perfect sense to me about how those winds occur. All of our winds are occurring for something like that, but there are things that are more complicated. So you have pressure differences. The local differences in heating cause small winds. Bigger differences over larger ranges cause the bigger differences. So when you have something like the Chinook winds, if you're up in the Northwest, or the Santa Ana winds, if you're down in Southern California, those are caused by big differences. Ocean, the Chinooks are ocean and then going out to, I don't think it's the Mojave Desert. I think it's the Saguaro Desert. What do they call the Sonora Desert? That's it, where the saguaro cacti are. Okay, I think we have two questions here. I may be wrong. Atmospheric pressure is greatest near the Earth's surface because. Renee has an evil answer. Answer all the ones that you believe are correct and hit enter. And Renee, evil laugh to yourself. Or if you're going to have an evil laugh, you have to, Yeah, there you go. Jocelyn's got that one down. I don't think so.
I'm not saying that's answered, but
Yes, because it's not.
I know, but can you do that, or will it not even enter?
I do not think it will.
Oh. That's what you mean now.
Okay. Eric, Tiffany, Jackie, Skyla, Jocelyn, Raquel. Eric, Skyla, Jackie, Raquel. Eric, Jackie, Raquel.
How many can you pick?
You could pick up to 4, I believe. So still Jackie, Raquel. Now just Raquel. So you put in your answers and then you hit enter.
Oh,
There's no. Oh, yeah, there's no answer button.
yeah.
Okay, what's it called then?
You can
Return? I don't know.
No, nothing.
Yes, no. I don't know what to do.
Well, you've answered enough questions. You're going to get credit for today, so I'm going to go on. So we had 14, 15, 6, 7. Jocelyn, justify an answer.
Well, I honestly picked all of them because no science behind my reasoning. I just figured because you gave us the option to choose more than one, I just was like, oh, all of them. I started with B. I don't know if that was a good place to start. Just felt like it sounded really sciencey. Then I moved on to A, and then C, then D. Yeah.
Okay.
Sorry.
Yeah, it's okay. I hold no grudges. Skyla,
Okay,
defend one.
just one.
Yeah, just one.
Well, I put B because was one of the ones that I put. Because I couldn't remember the exact percentage, but I remember that part. So.
Okay, the percentage is right.
Okay.
But-
That's why I did that.
Why would that make it have a higher pressure? I'm guessing it's not coming to you. I don't want to just have you sit here on the spot for. Okay. Well, Earth's air pressure is the result of the weight of the air above us. Answer A. And so, since 90% of the air is down in the troposphere, then if you're above the troposphere, there's really not much weight above you, right? So down the troposphere is where we have, the Earth's surface, where we have the highest pressure, because that's where you have most of the weight. If you go up above the Earth's surface by much, you don't have nearly as much air above you. So the correct answers were these two. Now, of water temperatures, because of water temperatures, or warmer temperatures, excuse me, I mixed the two. Warmer temperatures are actually going to lower pressure in general. And water vapor, the water vapor actually lowers the weight somewhat because it's less dense in the air displaced. Or so they taught me in another class. So important things for driving weather conditions. Warm air has lower density and lower pressure, and thus it will float up. Cool air has higher density and higher pressure. So warm air will float up. Cool air with its higher pressure will push in and take its place. I already mentioned this. Land heats up and cools more rapidly because it has a lower specific heat. That high specific heat of water keeps you having the temperate temperatures near water and not having big changes. So this is the last of our clicker question. Hopefully you can answer this one, Raquel, because if you don't get it on this one, then it will be bad for your grade. At a hypothetical schoolyard, there is a blacktop area and a grassy area. On a particularly warm day, a small breeze develops between the two. So you have air blowing from one of those regions to the other one. Which way is the air going to move? Is it going to move from the grassy area to the blacktop, or from the blacktop to the grassy area, or from low pressure to high pressure, or is there not enough information? I did not put the grid on, so I can't tell who has answered. So Raquel, you're going to have to check for yourself to make sure you've answered. Actually, I figured out how to turn it on. So it's Eric and Raquel that don't have answers in yet.
What channel is it?
33. There, she's in. Now she's good. Okay, so we had a majority said blacktop to grassy area. Hannah, Ms. Moralia, is that what you said?
Yes.
Why?
Did you say blacktop grass area?
Yes, I did.
No, I said grass area. Blacktop.
Okay, so why did you say that one?
Well, I thought that it had to do with the convection cycle. So the grassy area was the ocean and the blacktop was the warm land. So the warm air over the blacktop rose, and then the cooler air from the grassy area flowed.
Oh.
She's correct.
I didn't think it was.
Okay, good. Because she's exactly right. It's just like the example I use. The blacktop is going to be hotter, and so that air becomes less dense, warm air, less dense, floats up. The higher pressure, lower density cool air then comes in. And the blacktop is going to, we probably know it absorbs more light, it gets hotter. Okay. Hey, Coriolis, I really want to talk about the Coriolis effect, but in 1 minute, there's just not enough time to describe the effect. So I will see you Wednesday where we will review.
Was our test on Friday?
I believe it is. Somebody said that was incorrect, but I think that they were lying.